Welcome back. Let's do a mesh current method problem. So we're given this circuit right here. The voltage source, 80 volts, and a resistor network. So this is 30 ohms, this is 5 ohms, this is 26 ohms, this is 90 ohms, and this is 8 ohms. And then we're asked to find the power in the 80 volt source, the power in the 8 ohm resistor, and the power in the 26 ohm resistor. Okay, so there's 4 loops around here. So, and we typically don't use the outside loop, although you could. But the 4 loops, and let's just go clockwise on all of these guys, which happens to work out for this guy, although you could go the other way. But the only independent device we have here is this little voltage signal, and let's come out of the positive terminal is kind of what you want to do for these loops. So what we're doing with mesh current method is you're summing the voltages, and you're using V and IR terms. Okay, you're summing voltages around a loop, and the terms are going to be voltages, either direct voltages like this one, or they'll be voltages determined from an IR by Ohm's law. All right. So let's see. There's some more rules. So when you go negative to plus, that's going to be a negative term, and then there's superposition. Now we won't see superposition in this particular problem, but we will in the next one. So yeah, we'll say that for later. So we go mesh current 1, or sometimes I'll write loop 1. So we go around this loop and sum the voltages. So coming into the negative terminal here, it's going to be minus 80 volts. Okay, then you just assume that the polarities are resisting the current flow. So there'd be a plus minus here and a plus minus here. But you don't really need to write those. You might later, but for now, here's what you do. You just use the I1 mesh current and then the resistance. So we're going to use an IR term. So it's just going to be 5 I1 for this guy, and then 26 I1 for this guy. So this is what I like to call the terms due to, these are due to I1. These are the I1 effects, let's call it. And then, yeah, you do see superposition. So here we're going to apply superposition. So on all the elements in this I1 loop that are shared by another loop, you have to factor in the effects of that other loop. So basically these loops have independent effects, and you add them together. So this guy is shared, right? So this is going to be, the resistance is going to be 5I2 by IR, right? The resistance due to this I2 loop current is going to be 5I1. And then you compare the directions of the current. So like here, this I1 is going from left to right, but I2 is going from right to left through here, right? I2 is going to the left through this resistor, and I1 is going to the right through this resistor. So they're opposite. So it's a negative sign. And you could label this, you could say, because I1 and I2 are opposite, that's why that's negative. Okay, this is the effects, this is the I2 effects. All right, and then we have to figure this other shared component. The 26 resistor is also a shared component. So it's going to be, by Ohm's law, it's going to be 26 I3. That's the IR term. and then you have to check if the currents agree to get the sign. So in I1, it's going down through the 26 ohm resistor, but I3 is going up through the 26 ohm resistor. So these disagree. So the same thing applies here, that, well, actually, it's I1 and I3 are opposite. So that's a negative sign. Okay? So that's superposition. You do the main loop, you do voltage, voltage, voltage. Then you look for the shared elements. Like this element here is shared between I2 and I1. So you put that in there, and then it's opposite because the currents are opposite. And then this element is shared between I1 and I3. And it happens to be negative because the currents are opposite. Okay? And these are summed to zero because we've just summed voltages around the loop. Let's do it again. Mesh current 2. Let's go around this loop here, loop 2. Go around that guy. You're gonna get 30 I2 plus 90 I2 plus 5 I2. So these are what I like to call the I2 effects. So this labeling the effects is a good thing to do. This is the I3 effects. For this problem, it's not super complicated, but later on we're going to have mutual inductance and a lot of crazy stuff going on, and labeling where these effects come from is a good way to sort of check your work, make sure that it's okay. Okay, so this was the I2 effects, the voltages due to I2. Then you look at the shared elements. So we have a 5 I1 shared element, and we have a 90 I2 shared element, I3, 90 I3 shared element. And here the currents are opposite through this, so it's going to be negative. And once again, here the currents are opposite through here. And here I2 is going to the left, and I3 is going to the right. So this is a negative sign. So these sum to zero. One more time, mesh current number 3. You go around the main loop, you get 26 I3 plus 90 I3 plus 8 I3. So these are the I3 effects. And then by superposition, you look at the shared elements. We have a 26 I1 shared element, and we have a 90 I2 shared element. Those sum to zero. Then we just figure out the signs. So once again, I1 and I3 opposite directions, so it's negative. And I3 and I2 are opposite directions, so it's negative. So those are the equations. We're almost done. We put it in standard form so that we can stick it in our calculator, and it's going to look like this. It's going to be 31 I1, because if you add up all of these, 26 plus 5 minus 80 is 31 I1, and then you end up with a 5 I2 here, and you end up with a 26 I3, and those sum to zero. And that was equation 1, and then equation 2 and equation 3. You're going to end up with minus 5 I1 plus 125 I2 minus 90 I3. Those sum to zero. And then this last guy, you're going to end up with minus 26 I1 minus 90 I2 plus 124 I3. Just collecting terms and putting it in standard form. Then my calculator says I1 is 5, I2 is 2, and I3 is 2.5 amps. Those are the 3 mesh currents. Okay, we can do the powers now. So the power in the 80 volt, we can just use IV. Power equals IV. So this the current through this device is just 5 amps. It's I1, so it's 5 amps times 80 volts. It's an 80 volt source, so this is going to be 400, and the current direction is going from minus to plus, so this is delivered. It's a source. That's one answer. Then the power in the 8 ohm device, we could use I squared R, and the 8 ohm, where is it? There it is. The current through this 8 ohm device is just I3, so that's 2.5 squared, and it's 8 ohms. So this is going to be 50 watts absorbed. This is watts. 50 watts absorbed. And the power in the 26 ohm resistor. Okay, here, the 26 ohm resistor is in between these two loops. That is, we need to apply superposition here. So the basic idea with mesh current is that you're writing these equations as if each of the mesh currents is operating independently. And then you, if you need the actual current, and I'll talk about that in the next example, you need to add these two loop currents. So that's what we have to do here, and I'll talk about it more later, but it's going to be I1 minus I3 quantity squared 26. So this is superposition here. This is the actual branch current. Actual branch current via superposition. So we have to add the two loop currents to get the actual current that's in here. And this is the actual current, and I did I1 minus I3, and it doesn't matter really because you're going to square it, okay? And you'll get a positive number. So this ends up being, gee, I don't have the answer written down. Well, it's going to be I1 was 5 and I2 was 2.5 quantity squared 26. It ends up being 162.5 watts absorbed. All right. That was a basic mesh current method. Hope that was helpful to you. See you next time.